Welcome to Eco Engineer. Today I will discuss about rectifier and what are the rectifiers, off-wave rectifier, full-wave rectifier. Today I will discuss about what is rectifier and off-wave rectifier. Off-wave rectifier construction and operation, how it can be operate, and the basic construction structure of an off-wave rectifier, and off-wave rectifier input and output waveforms with diagram as shown. Let's go to the topic. Here we have to see that what is rectifier. Rectifier is defined as an electronic device used for converting AC voltage to unidirectional voltage. This is nothing but when you have applied to the AC voltage to the rectifier to convert that AC voltage to DC voltage or like a unidirectional voltage. Okay, here a rectifier utilizes unidirectional conductance device like a vacuum diode or PN junction diode. Okay, rectifier are classified depending upon the period of conductance. Here, conductance due to the period of conductance, rectifiers are classified in two types. There are off-wave rectifier and a full-wave rectifier. We have to discuss about now off-wave rectifier. A off-wave rectifier is one which converts an AC voltage into a pulsating DC voltage using one half of the applied AC voltage. When we have given apply the voltage sinusoidal wave signal AC voltage which is converted by an off-wave rectifier to produce a pulsating DC voltage. Okay, the rectifier diode conductance during one half of the AC circle only. When this journey ఇక్కడ we have observed this one, this is positive half cycle, this is negative half cycle. We have this output waveform. The positive half cycle gives the DC pulsating or form will be obtained in outside, and the negative half cycle cannot form a voltage in the outwave waveforms. Here, the basic off-wave diode rectifier circuits along with its input and output waveforms in shown in the figure. The AC voltage to be verified is applied to a single diode connected in series with a load resistance RL. Here we have observed the circuit diagram of an off-wave rectifier, the basic structure of an off-wave rectifier. This is a primary coil, this is secondary coil. Okay, this is parallel plates which is to the two primary coils. This is input signal, this is output signal. The input signal is AC signal, AC input, AC voltage. This output signal is DC voltage, DC signal. Here the load resistance is nothing but RL. This is a diode. The diode which is converted is this terminal is called as the positive terminal is called as anode. This negative terminal is called as cathode. Okay, here when we have applied the voltage, the AC voltage, this is called as the input sinusoidal wave voltage applied at the primary coil. We have observed this, the output wave from the pulsating DC voltage is like that, like this. Okay, this positive half cycle, as the negative half cycle cannot work on the off-wave rectifier, and we have to form the positive half cycle. This positive cycle form. Here the values is nothing but 0, pi, 2 pi and 3 pi. This is nothing but omega t is nothing but a sinusoidal wave. Okay, this Vi is nothing but input voltage. Here Vm is nothing but peak inverse voltage. Okay, let Vi be the voltage is the primary of the transformer by given by the equation Vi is equal to V input is equal to peak inverse into sinusoidal wave. Okay, now we have to discuss about the description of an off-wave rectifier. Here, when VR is a cut-in voltage of the diode during the positive half cycle of the input signal, that anode of the diode becomes more positive with respect to the cathode, hence the diode is conductance. When have to see the diode. The anode terminal become act as a positive and the cathode terminal acts as negative. Then we have formed a forward bias conductance. The diode is in conductance mode. Okay, when the ideal diode forward voltage drop is zero, as show that input voltage will appear across the load resistance RL. Okay, when we have to increase the input voltage, the load resistance is appears on the RL of which is connected in parallel to the rectifier. During the negative off cycle of the input signal, the anode of the diode becomes negative with respect to the cathode. Hence, the diode does not conduct. In this case, when the negative terminal of the anode of the diode becomes negative one with respect to the cathode. Here, the diode can act as a reverse bias. This does not conductance. Here, for an ideal diode, the impedance of offering the diode is finite. So, the whole input voltage appears across diode D. Hence, voltage drop across RL is zero. This is nothing but the output waveforms can be observed with the help of an oscilloscope by connecting it either the load resistance or else since awfully off cycle of the input wave is used, it is called as an off wave rectifier. Okay, we have seen that the waveforms of the input and output waveform we have seen in CRO cathode ray oscilloscope or CRT. We have observed this waves in this particular device CRO or CRT cathode ray oscilloscope. The load resistance RL here connected to the load resistance RL. Since only off cycle of the input wave is used, it is called as an off wave rectifier. Okay, in off wave rectifier, the diode is act as forward bias, it conductance. When the diode is in reverse bias, this is not conductance. Okay, this is the major importance of off wave rectifier. The input waveforms and output waveforms. Here, the positively off of the cycle will be input wave is used. That's why it is called as off wave rectifier. So, thank you guys. Thank you very much.